Hi, in this video I want to demonstrate an update, an enhancement to my HyperCore version fleet update video that I posted recently. In this particular video, I've actually added monitoring for the update process. I've also added the ability to, on single node systems, such as this one shown here, to automatically shut down running VMs, do the upgrade, monitor for success or failure, and then restart the virtual machines afterwards. So let me kick this off here. So I just did a run across this list of clusters. You can see that OZT60B, which is this cluster here on the right, shows as failed. That's actually expected in this particular case because it's an older hardware cluster with an end of life limit at 923. So while in our lab it is able to see, and I'm trying to, I specified the desired version is 927. So it's going to try, based on the inventory, to update that. It's not going to be able to, and so that's why it's failing. So it's going to initiate, kick off, and then terminate quickly, which is fine. And it's a multi-node cluster, so there's no need to turn off VMs. The single node system here, I went back to a fairly old version so that I could run this demonstration a bunch of times. Has a number of VMs running. It's currently running 9113. However, in my inventory file, I here now just set the desired HyperCore version to 914. So let's go ahead and initiate this playbook, and we'll see what happens. And I'll kind of walk through some of the playbook as it runs. So I'm running this against all systems in region 1 for my inventory, which is this list of clusters. It's allowing them to run out of order, so we're not going to see everything running all at the same time. In other words, some clusters will be farther ahead in their tasks than others, but you can see here, so we did see some versions that are out of compliance. So ZT60, it's trying to apply 927, and it's available. So we see that message here. There's probably some other messages we missed about this version, but it's already at the point here where it's shutting down these virtual machines. And we do have control in the playbook. It's first requesting a clean shutdown. There's a timeout parameter that you can actually set in Ansible for how long to allow those to shut down cleanly, and after that it would force them off if it needed to, and it will wait for that to occur. But you can see that that's now occurred. You can see it's logged the virtual machines that were shut down. The OZT60B is already in the executing state here, so we can see that happening there. And again, these can happen out of order. So OZT60B will fairly quickly terminate. But let's look at kind of what it's running. So this is my main playbook here. There's a bunch of logic in here to, first of all, check to see if I even need to do an update. So if you're out of version compliance, that's the first thing it checks. And if there's no version to apply, it will end the execution. So that's what this end host meta task end host will do. Otherwise, it'll continue checking. The next thing we'll check is to see if there's the desired version available. If it's not available, then it will not operate. So you can see here, while this is still in the upgrade process, this has already gotten to the very end where it timed out. We saw it fail because it went to terminate, continued executing the play. There were no VMs to restart there. But then in the end, it did a last version check and said, nope, it's still out of desired version compliance at the end. So it reports failed, and we'll see this cluster as failed in the summary here. But going on to the playbook here, so we check to see if there is a version to apply. If there's not, it uses that meta task again to update or to terminate. If it's single node, so it looks at when the node count is not 1, it will get a list of all the VMs on the cluster. It creates an array to store the list of VMs. It iterates through those and finds the running VM. Adds to the array. It sets the power state to stop, looping across that. And then after that's all done, then it goes ahead and initiates the update. So this was a little interesting, the way that I had to do this here. It then goes to a separate include tasks playbook, which is here. And I had to do that because of the way I couldn't just use an until loop here to keep checking, because sometimes the whole web server's down when the node's rebooted, and this would fail in a way that it would no longer retry. There might be some other way to detect that kind of failure, but I did a bunch of searching, and this was the solution that I came up with. So basically, while this is a run until loop, when it can't get this response. When it can't register this variable, these will then be undefined, and that'll be a fatal error that will not retry again. So when that does happen, it just goes into this other loop where it basically recalls itself recursively. It does have a loop count, so would only do that a certain number of times. But that was a solution there to handle this, and we'll see that should most updates does come into play. I'm checking pretty often, every 10 seconds. So what we saw here, okay, we saw OZT60 failed. We see now that on this particular cluster, it's in this loop. So it was checking for updates. Maybe here, usually when this goes away, that's when the next check is going to fail. You get that catastrophic failure, and it would kick into the outer loop. And there's some messages that you'll see when that happens. Just a refresh here. Usually it's somewhere in here where you see the updating storage node packages, and if you do see a node reboot in some of the update paths, you'll certainly see this. So it is just checking this update status.json file. It's looking for these fields, the master state, if it either goes to complete or it goes to terminating. Those are triggers that the update's complete, and it can execute the loop. Wow, this may be an update path where it may not restart the server, or I may have just might have happened quickly enough where we didn't have a fatal error. So, and that's totally possible. I mean, it could just execute in this loop. That was the original design, and the first couple testing. Oh no, here it's rebooting. So I think when it's rebooting, you're going to see that the next update, the server's going to be completely down. This will take a little while. This will go away, and then that's when it'll go into this outer loop and retry. Yep, there you go. Normally this will report failed retrying, but here you got basically the variables are not defined. So I can't check the condition. That's when it's going to go into this outer loop, increment the retry count. It's going to wait 60 seconds. It's going to try again. And the way I have this set right now, it could try this 5 times if it needed to. Okay, well, so the UI is back. You can see it took several loops, so now it's back just in the normal, it's getting a response now. So now it's back in this normal loop here where it's just looking for the right response. And just for fun, this is what it's looking at, is this information here, which it's just pulling that in JSON. It's looking for that particular field. And that was a pretty handy way to monitor. So we'll take a look here. Basically, when it comes back, we're just going to print out the variables that were stored before. We're going to go through the same kind of loop we did before. And the way this is structured, this would actually, if for some reason we tried this a little too soon or something, this should, as it's written, keep trying until the power state is started. But it's setting the power state, which should be enough to the module itself should wait for that, is my understanding. But originally, rather than monitoring, I considered a solution where I just did this, just restarted the VM until it worked. And then it does a last version check. And in this version check, I did just here, ignore errors. No, earlier in the playbook, I said ignore errors, yes, because that's kind of what it was looking for. It was using the built-in fail, which is probably not the right thing to use up above. But here, if it is set to fail, if this test is not true, which if it has not been updated, will not be true. Okay, so now update is complete. You see that loop. It does the final report, or what, on the status. See it start to restart those VMs. Keep in mind that, in this case, we just had the two clusters with any changes. We had this cluster that terminated. We had this cluster that did have a desired version change. But the way this playbook is structured, this could operate across, any number of systems, whether they're single node, multi-node, whether the updates are successful, failed. Um, Looking for feedback, input, better ways to do it, better error checking. But this looks pretty complete to handle a pretty wide range of HyperCore update deployment scenarios. Thanks.